All right, this is a little mathematical lemma, a little helper theorem. And here's a unit circle. This is the center. X goes this way, and Y goes this way. If I have an angle, theta, let's say, like this, then 2 theta looks roughly like this. This is 2 theta right here, 2 theta. And the sine of 2 theta is y for 2 theta divided by the radius, which is 1 in this case. So this is the y associated with 2 theta. I'm going to call that y sub 2 theta. There's also, in the second quadrant over here, another angle. There's another angle measured from the origin around like this, which I'll call gamma, just for purposes of discussion here, gamma, such that its y is exactly the same. That is, y sub gamma is equal to y sub 2 theta. So that the sine of 2 theta and the sine of gamma are the same. In other words, here, let me move this just a little bit. Sine of 2 theta is equal to sine of gamma. And what I'd like to find some angle alpha in the first quadrant. I'm just going to call it this. This is angle alpha, such that the sine of 2 alpha is equal to the sine of 2 theta, where alpha is not equal to theta. So anyway, from this equivalence, I have that 2 alpha is equal to gamma. In other words, I can write that gamma is equal to 2 times alpha. I'm going to use that in just a bit. So if I look at the picture here, I can also say, let me move this up a little bit, I can also say that gamma, this angle here, gamma plus 2 theta, which is what this one, this angle is, this is also 2 theta. I can say that gamma plus 2 theta is equal to 180 degrees, which means that gamma is equal to 180 minus 2 theta. But up here, I have that gamma is equal to 2 alpha, so that's equal to 2 alpha. And then this tells me, if I divide both sides by 2, that alpha, the angle I'm looking for, is equal to 90 minus theta. Okay, that's the result I wanted to find. An angle in the first quadrant such that the sine of 2 alpha is equal to the sine of 2 theta. And the reason for this is to use in the range problems.